Welcome, welcome. This is for March 13th, 2025. And so this is the quiz number 2. So the given equation was a velocity equation. Negative 0.25 t squared plus 2t squared of this to the power of 3, minus 3t. Now given these values, we were to find the maximum velocity and the initial position of the object at time t equals 6 seconds. And so how do you get from a velocity equation to a position equation? Well, you integrate it. Since we know that x of t was the integral of v of t, that equals negative 0.25 over 4, since you raise it to the power of 1 and divide it by that number, plus 2 over 3 t to the power of 3 over 2 to the power of 2. You have now your equation. So it's very simple. 6 seconds, we'll just plug it in. So you have this, plug it in here, you plug it in the second time here, and you plug it in lastly over here. And so once you plug in all these values, your initial position, or not your initial position, the position you have at t equals 6 seconds should be 9 meters per second. This is more of a review question, something we went over in the second or third week of school. And so just a quick little review. The integral of velocity is a position. Just plug in t equals 6 seconds into that, you get 9 meters per second. Now we got a little bit more complicated, and so let's keep this. Let's keep our velocity function. Keep that. And so once we have our velocity function, we were to find what is the maximum velocity of this object in motion. What is the fastest that it goes? And so a way to find this is to find the local maximum and minimum of the values, the critical point of these values. And so how do you do that? You find the derivative of velocity. And so once you have these values, it should be, since you multiply it and then subtract it by 1, it's negative 0.75 t squared. It was from 3, went down to 2, plus 4t, and multiplied by 2, now it becomes a 1, and it would just be negative 3. And so how do you find the critical points? Well, you set this derivative equal to 0. And so I'm sure you guys can see what we need to be doing now. Once we have this, we just use a quadratic equation, quadratic formula. I'm sure you guys all know it as negative b, and just like this song I learned in my sophomore year of high school, negative b plus or minus the square root b squared minus 4ac all over 2a. So displaying what the quadratic formula is. And so let's plug that into the equation right now. What I actually did when I was solving it is because, I found this negative. I didn't like the negative sign in being in front, and so I kind of just got rid of it. So it would be 0 equals 0.75 minus 4t plus 3. Just everything left and right of the equation, multiplied it by negative. Obviously, with doing it to 0, it doesn't affect the left side, but now it looks more cleaner, or just cleaner to me. It doesn't matter, you don't have to do it, but that's just something that I did. And so going back to the quadratic formula, where t equals, and so we get negative b, so negative 4, so negative it'd be 4, plus or minus 16, since 4 squared, minus 4a, so 0.75c, so that's 3, all over 2, and then 0.75, which would equal 1.5. And so when you use and plug this into your calculator, your two values that you should be getting is 4.43 seconds and 0.903 seconds. And so now what? Now, Andrew, what do? You get two different values. How am I supposed to know which one is the maximum value and which one is the minimum value? There's multiple ways of going about it, testing the values, testing the numbers before 4.43 and after 4.43 to check it's a maximum value. Same thing with 0.903 and plugging that into the original equation. But I mean, for me, the more simple, something that makes more sense to me is using the second derivative test. And so deriving this formula that we have here one more time. to second derivative, which would equal 0 or negative 1.5 t plus 4t. You drop the 3 because it has no t. And so now once we have it here, you plug in the times that you get. So these right here, 4.43, and if you put it into your calculator, you should get negative 265 and 0.903 equals 2.645. And so now what do you do with these values? You get a negative value and you get a positive value. Well, what the second derivative test says is if the second derivative is greater than 0, it would be a local min. If the second derivative is less than 0, then it will be a local maximum. And so given our two values, this right here is going to be our local maximum. And so once we have that, and we know that time 4.43 seconds is going to be when the object is at its fastest, we can plug this into the original equation, velocity equation. So we get 4.43. If you just plug this into your calculator, you should get roughly 4.23 meters per second. And so that's what we have for today. A quiz question. Just a review on kinematics and calculus, or not, well, I guess kind of kinematics and calculus, more working with the velocity formula. And so just to review, once given the velocity formula, we found the derivative. We used the derivative to find critical points. So when it changed from a negative to a positive value, or positive to negative, and we use the quadratic formula, negative b plus or minus b square root minus 4ac all over 2a. And so once we plugged in these values, we get 4.43 and 0.903 because it's plus or minus. And then given these, we use a second derivative test where we know if the second derivative test is greater than 0, it's a local minimum. If the second derivative test is less than 0, it'd be a local max. And so once we plug these values in, we get a negative value and a positive value. And given these, we pick obviously the 4.43 seconds, given 4.43, we plug that straight to our original equation, and we get 4.23 meters per second as our fastest time. And so this is my last video before we have an exam. So if you guys are actually watching to help review, or if for any other class or whatever, I hope it was good review. Hopefully I'll get better at explaining any of these topics, and hope we continue to learn in this class. And so thank you guys for watching, and I'll see you guys next week.